In this video, we're going to explore angles formed by chords, secants, and tangents. To start off, we have a little bit of terminology review. We have a chord, which is a line segment that connects 2 points on the circle. We have a tangent, and that's a line that touches the circle at 1 point. And we have a secant, which is a line that intersects a circle at 2 points. To start us out, we're going to look at Theorem 1212, which says the measure of an angle formed by 2 chords that intersect a circle is half the sum of the measures of the intercepted arcs. I want to point out that we're dealing with 2 chords here, and that we're dealing with the angle here. That angle is going to be equal to half the sum of those intercepted arcs. Intercepted meaning the pieces in between those chords. And our second theorem for today is talking about the measure of an angle formed by 2 secants, 2 tangents, or a secant and a tangent drawn from a point outside of the circle is half the difference of the measures of the intercepted arcs. So the angle in each of these cases is equal to half of the difference of the intercepted arcs. Notice in the case of the tangents, in part 2, tangents here, the 2 arcs should add up to 360. Alright, so let's try out a few examples. In this first example, we see 2 chords hanging out. So I'm thinking that the measure of angle 1 is equal to half of the sum of the intercepted arcs. Well, the sum of the intercepted arcs, we're dealing with a 55-degree arc and a 35-degree arc. So the measure of x is equal to 1/2 of 55 plus 35. So x is equal to 1/2 of 90. So the measure of x is 45 degrees. In this next example, I see 2 secants that are meeting at a point outside the circle. So I'm thinking about the formula, the measure of angle 1 is equal to 1/2 of the difference of the intercepted arcs. So here's my angle 1, and my intercepted arcs are going to be this piece and this piece. So 130 would be my x, and I'll keep y as y. So 35 degrees is equal to 1/2 times 130 minus y. To solve for y, I could choose to multiply both sides by 2, which leads me to 70 equals 130 minus y. I could then subtract 130 on both sides, leading me to negative 60 is equal to negative y, and divide both sides by negative 1, so my value of y is a positive 60 degrees. In this next diagram, I see 2 secants that are meeting at a point outside the circle, but in this case, I want to solve for my angle measurement. So I'm still thinking about my formula. The measure of angle 1 is equal to 1/2 of x minus y. So in this case, I'm looking for z, that's my angle. My intercepted arcs are this 170-degree arc and the 90. So I'm going to think z is equal to 1/2 of 170 minus 90, where z is equal to 1/2 times 80. So z has a value of 40 degrees. In this last problem, we have a couple ways to look at it. It says, using a zoom lens, a photographer focuses his camera on a fountain. His camera is at the vertex of the angle formed by tangents to the fountain. He estimates this angle is 55 degrees. What is the measure of the arc of the circular basin of the fountain that will be in this photograph? Well, I have 2 different ways to look at this. I mentioned before that if we have tangents, the 2 pieces of arc together add up to 360. So if this bottom piece is x, then this top piece has to be 360 minus whatever x is. So if I'm thinking about my formula with 2 tangents, I'm thinking of the measure of angle 1 is equal to 1/2 of x minus y. Well, the measure of angle 1 is 55 degrees, is equal to 1/2 times the big arc minus the little arc. So 360 minus x. I can combine some like terms. For 55 equals 1/2 times 360 minus 2x. I can multiply both sides by 2 to get rid of that 1/2 fraction. So 110 is equal to 360 minus 2x. I can subtract 360 on both sides, leading me to negative 250 is equal to negative 2x, and divide both sides by negative 2, and the value of x is 125 degrees. All right, that way was fine to look at it. We could also look at it in a slightly different way, using other properties of tangents. This way is less complicated. We notice here that this is a radius connected to a tangent. Radius, tangent. Anytime we see a radius and a tangent meeting, we're thinking 90 degrees. I now notice that I have a quadrilateral. My quadrilateral angles have to add up to 360, so if I take 360 and subtract 90 plus 55, I'm left with 125 degrees.